Let's now discuss how you would go about factoring a quadratic by removing the greatest common factor. To do so, we must first discuss the concept of distribution. So let's say we had 2x times x plus 3. A term on the outside of a set of parentheses is distributed to each term inside of the parentheses. So 2x times x would give you 2x squared. And 2x times 3 would give you positive 6x. And once the term is distributed, then it is a common factor in each term of the product. So 2x can be removed from 6x, and 2x can be removed from 2x squared. So reverse distribution is what we will use to find the greatest common factor of a quadratic with a single variable. So if you had 2x squared plus 6x and wanted to remove the greatest common factor, the first thing you do is remove the largest number that is a common factor of the coefficients. In this case, our coefficients are 2 and 6. So the largest common factor between 2 and 6 is 2. If you're not sure, you can create a prime factor tree for each number. So you can remove 2, and then you go to the like variables. In this case, we have just a single variable x. Later in the chapter, we'll be removing greatest common factors for terms with multiple variables. But in this case, we have x squared and we have x. X squared is not common to both. This term only has one x, but x is common to both. We have two x's here, we have one x here, so we can remove one x from both terms. So x is our greatest common factor between x squared and x. So once we've removed the largest factor of the coefficients and the greatest common factor of our variable, we wind up with 2x on the outside. So our factors would be 2x and x plus 3 for 2x squared plus 6x. Now, let's say you're asked to factor by removing the greatest common factor and check the answer for 4x squared minus 12x. How will we go about doing so? Step 1, remove the greatest common factor from the coefficients. So the greatest common factor between 4 and negative 12 is 4. We then, step 2, remove each variable and the largest exponent that is common to each term. X is common to each term, not x squared, since this term does not have two x's. So the greatest common factor between these two terms is 4x. And now to figure out the second factor, you want to divide each term in the original polynomial by the greatest common factor, 4x. And when you do so, 4x squared divided by 4x would give you x. 4 divided by 4 is 1. X squared divided by x is equal to x. 1 times x is just x. And now you divide the second term by 4x, giving you negative 12 divided by 4 is negative 3. X divided by x is 1. Negative 3 times 1 is negative 3. So we wind up with the factors of 4x times x minus 3 as our answer. And now step 4, check the answer by multiplying the factors. If we multiply these two factors, we should wind up with a product of 4x squared minus 12x. 4x times x is 4x squared. 4x times negative 3 is negative 12x. So we do wind up with our original polynomial, which confirms that 4x times x minus 3 are the factors of 4x squared minus 12x. So that is how you factor by removing the greatest common factor for polynomials with a single variable. Let's have you complete a few practice questions. Question number 1, factor by removing the greatest common factor and check the answer for 14x squared minus 7x. Question number 2, factor by removing the greatest common factor of 16x squared minus 12x and check the answer. In question number 3, factor by removing the greatest common factor of 30x squared plus 45x and check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We wanted to factor 14x squared minus 7x by removing the greatest common factor. Step 1, remove the greatest common factor from the coefficients. And we have 14 and negative 7. Common factor is 7. We then take a look at our variable, x squared and x. We remove each variable and the largest exponent common to each term. X, the largest exponent common to each is 1. We have 1x here. We have 2x's here. 1 is common to both. So 7x is the greatest common factor of 14x squared minus 7x. To find the second factor of this expression, we want to divide each term in the original polynomial by the greatest common factor, 7x. When we do so, we get 14 divided by 7 is 2. X squared divided by x is equal to x. This exponent 2 subtracts this exponent 1 to give us an exponent of 1. We then divide the second term in our original polynomial by the greatest common factor, giving us negative 7 divided by 7 is negative 1. X divided by x is 1. Negative 1 times 1 is negative 1. So the factors of 14x squared minus 7x are equal to 7x times 2x minus 1. Step 4, check the answer by multiplying the factors, giving us 7x times 2x, which is 14x squared, and 7x times negative 1 gives us negative 7x. So this confirms that the factors of 14x squared minus 7x are equal to 7x times 2x minus 1. So that is the answer to question number 1. Let's have a look at question number 2. We were asked to factor 16x squared minus 12x. Step 1, remove the greatest common factor from the coefficients, 16 and negative 12. That would be 4. Step 2, remove each variable and the largest exponent common to each term. We have x squared in one term and x in the other term. So the largest x would just be x. That is common to both. So the greatest common factor of 16x squared minus 12x would be 4x. And now to find the second factor, the third step is to divide each term in the original polynomial by the greatest common factor, 4x. When we do so, we get 16 divided by 4, which is 4. X squared divided by x is equal to x. 2 minus 1 would be x to the first. And now we divide the second term, negative 12x, by 4x, giving us negative 12 divided by 4, which is negative 3. X divided by x is equal to 1. 1 times negative 3 is negative 3. So when we factor 16x minus 12x, we wind up with 4x times 4x minus 3. The fourth step, we can check the answer by multiplying the factors, 4x times 4x minus 3, giving us 4x times 4x, which is 16x squared. And 4x times negative 3 would give us negative 12x. So this confirms that when you factor 16x squared minus 12x, you wind up with 4x times 4x minus 3. So that is the answer to question number 2. Let's now have a look at question number 3. We were asked to factor 30x squared plus 45x by removing the greatest common factor. So step 1, we start by removing the greatest common factor, the coefficients, 30 and 45. And the greatest common factor of those two numbers would be 15. Again, if you weren't sure of this, you can create a prime factor tree for both these numbers. Step 2, remove each variable and the largest exponent common to each term. We have x squared and x. X is common to both, not x squared. So x is a part of our greatest common factor. The third step, in order to find the second factor of this expression, you want to divide each term in the original polynomial by the greatest common factor, 15x, giving us 30 divided by 15, which is 2. X squared divided by x is x. And now the second term, 45 divided by 15 is positive 3. X divided by x is 1. 1 times positive 3 is positive 3. We wind up with 15x times 2x plus 3. And now we want to check the answer by multiplying the factors, giving us 15x times 2x, which is 30x squared. And 15x times 3 would give us positive 45x. So since this is our original polynomial, that confirms that when we factor that polynomial, we wind up with 15x times 2x plus 3.